welcome to Test Driving Apache Tomcat 11. I'm a senior enterprise architect for Perforce OpenLogic. I've worked in proprietary J2EE application servers before moving entirely to open source servers such as JBoss and Wildfly, Glassfish, Apache TomEE, and Apache Tomcat. So I've got about 17 years total with Apache Tomcat. I think that was when version 5 or 6 was out. I've got about over 20 years of development experience with Java technology, doing full stack development and supporting it. And my primary focus right now is helping customers apply open source in the enterprise. So Apache Tomcat 11, I apologize, the top's cut off a little bit. It's nearly 25 years active. It was donated to the Apache Software Foundation back in 1999. There was a 2023 Jakarta EE Developer Survey. The results were in last month, and they asked, what application servers were you using? And Apache Tomcat came in first at almost 42%, and Wildfly was a second distant at 18%. There were over 2,000 respondents to this survey. Tomcat 11 is currently in milestone 13. The APIs, though, have not been completely finalized yet. It is based on Jakarta EE 11. Which is currently not out. It does require JDK 21, which is an LTS release at a minimum. That was released last month. You can actually get pre-built OpenJDK 21 available at Eclipse Temurin as of probably 5 days ago. The big feature with JDK 21 is virtual threading through Project Loom, JEP 444. The JDK requirement 21, that's a very aggressive move by the community, and that might delay adoption of it. Code comparison between 9, 10.1, and 11 are very, very similar. 11 could be production ready right now. The technology compatibility kits are currently being refactored to ensure it meets Jakarta EE 11 compliance. The release date, tentatively June, July of next year, and that's also dependent on the EE 11 release. 32-bit Windows, no longer supported. You will not find a JDK or JRE for it. The updates to Tomcat 11 and Jakarta EE 11 are mainly specification and RFC updates. So the beginning of this year, the Jakarta EE Working Group, they defined high-level guidelines for this release of Jakarta EE 11, and the theme was performance and developer productivity. All the EE10 deprecated features were removed. Now Tomcat, I'm sorry, there are 42 individual specifications, and Tomcat implements 6 of these. Tomcat does not implement the full or web Jakarta EE 11 profile. TomEE does implement the web profile. So the specifications for EE 11, those need to be done by the end of November next month for the EE release to be on time the middle of next year. If you're interested, there is a Jakarta live stream, and this is regarding the Jakarta EE 11 milestone 1. That'll be on December 5th, 2023. The link is in my presentation here if you're interested. So the specifications that we'll be just touching on are the ones that are in bold. The ones with the Tomcat symbol is what Tomcat actually implements. There are 3 candidate specifications, one that will be included in EE 11, which will be Jakarta Data 1.0, and the other 2, MVC and NoSQL, those are likely to stay candidate specifications. Let's talk a little bit about Jakarta Servlet. No major changes to this specification. It's mainly technical debt, clarifying vague and ambiguous areas. HTTP support is now mandatory, used to be optional. So this release, it removes references to the security manager, and you'll find that a common theme throughout the specs, and it provides various small enhancements and clarifications. So the security manager, it's been around for a while. It's been around since JDK 1. It has secured client-side code, and it's rarely ever used for server-side code, so it was removed. You get a bit more redirect control with the status code and response bodies you'll find throughout the EE 11 specification. And then also some of the other highlights, I don't want to go over all these because we only have 45 minutes, but for parameters, if this is different, if you do a get parameter on the HTTP servlet request, like for instance, if you don't have a foo input field, it's gonna throw an exception. That is different. You would typically get a null. Context route mapping, do you put the trailing slash or not put the trailing slash? It will map to both on your web apps. Also another change is they deprecated HTTP2 server push. It worked, but it really didn't do what it was intended for. And the idea of it is that you requested a web page, and the server anticipated that you're going to request the CSS, you're going to request the JS, and it actually caused a lot of unneeded trips back to the application server. That was replaced by the HTTP status 103 early hints. Also for the Jakarta server pages, notice I've got server in parentheses, it's now called Jakarta pages. It is mainly technical debt cleanup, some dependencies removed on the Java Bean spec, Java desktop module. You no longer have the ability to embed Java applets in browsers. It is a security issue. Not a big change since browsers don't allow that anymore. So the later releases, they'll be fixing unexpected issues and adapting to changes in the expression language. The EL, the expression language, just provides a small number of usability improvements. The Java Beans API is optional, entirely removed from the EL API. Used to be mandatory because of its dependency on Java desktop. So you had to bring in a lot of dependencies to use it, and not very many people were using it. Annotations, really no new features. Removed the deprecated managed bean annotation, replaced by context dependency injection. Jakarta authentication, unchanged from its previous release. Authorization, really hardly any changes there. Concurrency, this is a big one. This is Project Loom. This is JEP 444 that was introduced in Java 21, and we're going to cover that quite a bit here. WebSocket, really not much to mention here that I've got in the bullet points. Jakarta NoSQL, again, this is going to stay a candidate specification. So instead of several APIs to access a NoSQL database, there will be one. Jakarta Data 1.0, that will be included in the spec. It has relational and NoSQL support, pagination instead of rolling your own. I've had to do that hundreds of times in applications I've developed, so that's nice. Open Liberty right now, WebSphere Open Liberty is the only current implementer for Jakarta Data. So depending on what version of Tomcat that you're using, these are the different servlet, JSP, EL, WebSocket authentication specs that you would be using. And again, the Tomcat 11 implements EE11, and then there was a Jakarta EE8, which was just kind of like a namespace change, but it was really never really officially released with anything. Most of the customers that we support, these are generally the versions that I see people using. The ones that get my attention are version 7, which is end of life already, and then 8.5, which becomes end of life the end of March. And we have plenty of people on version 9. Security updates, there were quite a few here. Examples and documentation, web application. It's only accessible from localhost by default. Used to be able to access it from anywhere. So the reason for this might expose a cookie to an attacker is the reason documentation and examples has been locked down. So for instance, here's the main page, and if you try to get into examples, you're going to get a 403. Also, they're paying more attention to illegal headers and header mismatches. You basically can change the behavior on what's returned back to the request, whether it's a 403 or just entirely ignore it. So that is nice. They also added a rate limit filter. So this is if somebody just keeps hitting the server over and over and over, and it just prevents DOS attacks and brute force attacks that are allowed from like a single IP address within a specific period. They also, this is very cool, they added a TLS certificate reload listener. Now, I used to work in a large financial firm that had a database of certificates, and it would automatically send out emails if your certificate was going to expire. Well, this is basically what this does. So it'll monitor your certificates, and it'll trigger automatic reloading of the TLS configuration a set number of days for an expiration date. So basically, a restart would be required, or JMX command, to reload the certificates. It periodically checks on a frequency that you define, shows how close that cert is from expiring. If you don't update it, then it'll start logging warnings. You can actually integrate it with Let's Encrypt. This isn't a plug, but that's just kind of an example of a provider that you could use with this listener. Let's see here. So Project Loom. This introduced two new JEPs, 425 virtual threads and 428. Virtual threads, that was introduced in JDK 19 as a preview feature. So threads can be lightweight, and they're managed by the JVM and not the operating system. And you can have millions of these threads, and we're going to talk about that. Structured concurrency, it basically promotes a style of concurrent programming instead of async. So the goal for both of these combined is to improve the performance of code. You can code like sync, and it works like async. And I'll show this in a moment. This will definitely change the way that we code in the future. So let's talk about platform threads. Those are an operating system thread, and they're expensive to create, of course. So the OS has to allocate a large amount of memory in the stack to store the thread context, native, and the Java call stacks. Platform threads, they do wait until the operation completes. Now, virtual threads, or they used to be called fibers. Tomcat added virtual thread support earlier this year. So instead of the OS, they use the JVM heap for their stack, and they're not exactly tied to a dedicated platform OS thread. So virtual threads, they'll run within platform threads, which are assigned by the JDK and not the operating system. So there is a pool of these platform threads that do the work for the virtual thread scheduler. Virtual threads are non-blocking. If a virtual thread blocks, then it lets another virtual thread in that same physical thread. So large numbers of virtual threads, they can run concurrently, but you don't want to pool them. So once concurrency exceeds the number of CPUs, these threads are performed better than platform threads, especially like with smaller response sizes. And the last bullet point is very important. These type of threads, they're really good at waiting. So this is great for web applications where, like, if you make a request and it has to wait on the database for a while, or it has to wait on the broker, or some kind of external resource. So with virtual threads, you really don't have to write asynchronous code anymore that waits on resources. Instead, you can write it regularly synchronous style, and that makes the code more readable. So do you have to make changes to your code for virtual threads to work? You might, and you probably will. But I highly recommend that you perf test your application before you deploy it. Do I need to make changes to my existing code to take advantage of virtual threads? Definitely, and you may actually have to change some of your libraries as well. This could also have an indirect consequence on garbage collection. We could get better garbage collection with virtual threads. So the goal is to increase scalability without having to add CPU, RAM, or more hardware. So this is an example of code. They do exactly the same thing. The top portion actually is asynchronous code that gets images from an HTML page, and it's non-blocking. So as you go through the particular methods, it'll just basically just go away, and when the response is, the return value is ready, it'll come back and execute the rest. Now the code written further down, that's actually written in synchronous blocking style. So my question is like, what's more readable? I could write either, but I prefer to write what's on the bottom. So on the right-hand side, the way that this works, you have operating system threads. And in the middle, you have platform threads. And this is basically the java.lang.thread. And these platform threads are have a one-to-one mapping to the OS threads. And so on the left-hand side, you've got the virtual threads. Now notice, I've got 1 through 3, and I've got 1 million down here. This isn't a hard count. It could be several million. It just depends on the activity on the box. Now these virtual threads, they'll end up getting mapped to a platform thread. The platform thread then carries the virtual thread. So if a if a virtual thread does a blocking operation, such as a synchronized method or a synchronized block or a thread local, it gets pinned to that particular platform thread. The platform thread cannot release that virtual thread until it's done. And that's why you want to try to avoid synchronous methods. So just as a smaller example here I have 2 virtual threads. I have my heap, I have my platform thread. My virtual thread gets work. The platform thread carries the virtual thread. And then for some reason, let's just say the carrier or the particular virtual thread got blocked, whether it's waiting on the database, a middleware, or file transfer. What's going to happen is the carrier thread is going to get released by the platform thread, and the stack for that virtual thread gets copied to the heap. So that goes away. Now virtual thread 2 gets work, and it's assigned to platform thread 1. It does its work, goes away, and then now the platform thread can actually copy in the heap from virtual thread 1 and be assigned to that particular platform thread. An analogous story, I guess, in real life is, for instance, if you were returning something to a department store, let's say after the return period, and you went up to the cashier and she said, well, I need to get a manager for approval. I need you to step aside, I need to take the next person. And basically, she handles the return for the next person, and that work completes, and then you're brought back over to finish the work with the manager. That's kind of something analogous that I thought that is to this situation here. So how do I use virtual threads? You'd want to download a GA release of JDK 21. You can use JDK 19 or 20, but you have to use the enable preview JVM argument. Download Apache Tomcat 11, make the following change in server.xml, set your Java home, and then start up. So under the hood, this creates a virtual thread executor instead of a thread pool, standard thread pool executor to create threads. And this is like a line of code in the Tomcat code of which you'll see, thread.ofVirtual, which is a new method. So what I'd like to show here is a demo. I have 3 AWS instances. On the right, I have a JMeter running on a Rocky Linux instance. And what that's going to do a stress test against Apache Tomcat that's running JDK 21. This instance actually has an Spring REST application running Spring JPA, and it's going to hit the save endpoint. The save endpoint is just going to insert a record into MySQL database. And this is a snippet of the code it's very simple code that uses Spring JPA. You just create a product, set a name, price, and then save it to the repo. So let me go ahead and, I'll come back to the slide, but let me go ahead and kick off an example here. So right now, I have just this is standard threads, so false. So I'm not using virtual threads. I've already started up my server. So I'm just going to tail the log. And here I have a JMeter script that's actually going to hit that save endpoint, or URI. And it's going to run in non-GUI mode, and it's going to throw the output out in this directory. So I'll go ahead and kick that off. And let me go back to the slide. And so the example code for everything that I'm doing is out in GitHub. And there is another folder here, Spring REST Apache Tomcat demo. Again, there's nothing special about this code. It has nothing specific to virtual threads in it. That's the beauty of this. And so there's directions here on what you need to download, how you configure it in the server.xml, setting your Java home, how you would run the JMeter scripts, how to do like a database insertion test, and we'll do a couple other of these tests as well. So it's all in the README here. So let's go back to our run here. And so this, again, is running a standard thread test, a platform thread test. And from what I can see here is that transactions per second is just above 1,000. This here, I'm not sure how many have used JMeter before. It's a great tool. Average is 861 millisecond response time. Min is 6 milliseconds. Max is 3.2 seconds. Started 1,000 active threads and finished 1,000 active threads. So let's go ahead and run a virtual thread test. And all I would do is just simply go into server.xml. I have JDK21, set that to true. And I'll go ahead and stop my server. And then I'll go ahead and start it back up. And I'll go ahead and kick my test off. And just to make sure I have records in my SQL database, yes, they are accumulating. And you'll notice this new output here. These are pinned threads, but what I want to do is I want to issue a command that actually will give me a dump, which is not a great idea to do during a perf test, but for this. So I'm using jcommand, and I'm just going to output a text file for like a thread dump. So my test should be just about finished, but let's go ahead and just check what's in this parked. So what you'll notice as I scroll down through here, here's all my virtual threads. Notice how many there are. That's why it's important that these are not tied to like thread locals, because that would completely just crap your system out. But I should see something. Which you'll see in some of the threads for this NIO thread, it'll say park on carrier thread. That means this thread was blocked and it couldn't really do anything, so it had to wait on the database. So if I take a look at my output here, and I can see my throughput is kind of sporadic. You know, it's maybe no more than 800. If I go back up, where my standard threads were, it's much higher. And as a matter of fact, the JMeter reports, here's my standard thread report, and this is typically what I look at, is transactions per second. It's above 1,000. Now, if I go to look in virtual threads, 739, what happened? So let me go back to the slides here. So what had happened, what I noticed in all the runs that I did, and I did several, the black line is virtual threads and the blue line is standard threads. Standard threads perform twice as better than virtual threads. Well, there's a reason for this. If you go back and look at Catalina.out, you'll notice all these statements where it says monitors 1. That means this thread was pinned. It must have been in synchronous code. So there is a JVM option I haven't told you about that's new. How you would add JVM ops is you would create within Apache Tomcat Home, you would create a set env. And I have Java ops set to this trace pinned threads short. Two different options for this. Short is what you were looking at. It'll just show the one line section where a thread was blocked. You can do full, but that gives you the full stack trace of that particular pinned thread. And so that's kind of the output that you were seeing here. So if I take a look at the MySQL code, like on line 2005 and 2516, what you'll notice is that it was in asynchronous blocked. And it's the same thing for 2005. And these are long synchronous blocks. Synchronous starts up here. So this is something that you would want to avoid. Now, I'm not trying to dog MySQL JDBC driver code. It would just need to be rewritten as non-blocking code to take advantage of virtual threads. So this is very common, what I see in JDBC driver code, lots of synchronized methods. So the second type of test that I'm going to do, I was a little bit discouraged by the first test, but that's okay. Second test, let's see what we can get working here. So on the right side, I have, again, JMeter, and that's going to hit Tomcat, and the Spring REST code is actually just going to go grab the index page out of Nginx, which is about 28 bytes, I believe. So all it's going to do, if I can pull this up, that's it. I mean, that's just, it's going to do this thousands of times. It's just going to pull this page up. So let's go ahead and kick that test off. I'm going to do the virtual test first, virtual thread test. I'm not going to do the standard just because of time. So let's go ahead and shut the server down. I'm just going to clear out my logs. And it should already say use virtual threads true. Start my server up. And grab this command out of my cheat sheet. And my server's up. And I'm tailing the log over here. I'll let this start running. Already says I have a pinned thread. I'm using JSoup to actually go out and get a page. You could actually use your own library. So what's going to happen here in a second, see if this is still running here. And I'll just check HTTPD. Yes, I'm actually getting entries in my access log. Also keep in mind for these tests, on Tomcat, I have disabled the access log. That actually adds more noise to the perf test. And as you can see here, I'm throwing exceptions. So let's just take a look at Catalina out. Bind exception, cannot assign requested address. So here's what's happening. As the virtual threads are going out and requesting the index page off the server, the OS, it's requesting an ephemeral report, or ephemeral port. So to make a connection out to a server, you have to have a source port on the source server. And what's happening is that the OS is running out of ephemeral ports because the virtual threads are getting parked, and it just keeps piling up and piling up. So you'll see in the next slide here, this was a really bad test. Again, my standard threads, my blue line, my black line's virtual threads. I mean, it just was a bad test. As a matter of fact, my virtual threads, as you just saw, had an average failure rate of about 11%. And that is because if you take a look in your ephemeral port range, you can see I've only got 28,232 ports available. Now, when I ran this test using the standard platform threads, I did not run into this issue. So just keep that in mind. What I'm trying to get through is that you really want to perform it. Like if you turn on virtual threads, you want to make sure you performance test your app for things like this. Now, this is a bit of a contrived example, but something to kind of keep an eye on. So let's actually do a test that we might have some luck on. So again, my JMeter instance, it's hitting Apache Tomcat, the Spring REST web app. And what we're going to do, we're going to hit the multiply URI, and we're going to multiply doubles, random doubles, 50,000 times. So there's no synchronized code in here. There's no blocking code in here. And first what we're going to do, whoops, went too far. What we're going to do is we're going to run the standard test first. And let me get out of this, stop my server, remove my logs, and then we'll change that to false for platform threads. And then we'll go ahead and start the server again, tail the log. Go to my cheat sheet. And my server's up. Go ahead and hit that. That will kick off the multiplied doubles test, and we'll let that run. That'll run for a little over a minute. And I kind of want to go back to this real quick. For the JMX scripts are actually in a folder in this project. So if you go in here, a couple things you'll need to change in the JMeter scripts. Like if you go to just any of these, you'll have to change, of course, the host. I meant to change that before I put it out there, but that's okay. So you'd have to change that as well in each of the 3 JMeter scripts. Rest of this you wouldn't have to change. So this here would run a test of 200 seconds with a ramp-up time of 3 seconds. In my test, I have 60 seconds and a ramp-up time of 0 at the moment, but you'd have to change these 3. That's still running. And then you'd also have to change in the resources, in the Spring Boot application YAML, you would have to change the MySQL server here to whatever database you have. So let's go ahead and go back here. So standard threads, we've got our results here, transactions per second. So let's go ahead and run the same test with virtual threads. Tail my logs again. I didn't have any exceptions in my last run, which was great. I shouldn't see any pinning, virtual thread pinning with this test. My server's up. And let me copy my command to run my virtual thread test. Kick that off. And we'll just wait here for a minute. And let me go back to this and see if there was anything else here that you would need to change to run these. Yeah, again, this is trying to figure out if I remember. I think this class is not even needed, so that's something I forgot to take out. Not a problem. But these are the 3 main classes that you would need. This is your REST endpoint. That's got your URI mappings for like save, multiply, get page, things like that. So when we go back here for our virtual thread test, where we're multiplying doubles. Also, why this is running, I also want to show some of the graphs for page retrieval. Those aren't coming up for some reason. Okay, that's right, we didn't finish the test, but yeah, this was my page retrieval for virtual threads, and I had a 15% failure rate because of the ephemeral port exhaustion. Okay, this is done. So just already looking at the numbers, I can see the throughput is definitely higher. Let's go ahead and take a look at our graphs. This is for standard threads. So my throughput was, for standard threads, transactions per second, a little over 2,000. So let's take a look at our virtual threads. All of them passed, and 2,600. So that's actually a modest improvement. So the graph here shows transactions per second. When I ran different sets of 10 runs, I did notice that virtual threads were performed better. And this was 1,000 threads that ran concurrently for 200 seconds. Forget this anomaly here. The one thing I want to point out is virtual threads aren't necessarily faster but they're going to give you more throughput, so you don't have to add more hardware. So that's kind of the point of this. So really, the cases where you wouldn't get any benefit using virtual threads if you invoke native methods with JNI, and those perform like file I/O. Code changes, you're probably going to have to make some code changes or library changes that have a lot of long synchronized methods or synchronized blocks or thread local use, like the MySQL JDBC driver. If you do have synchronized methods, they should be brief. One of the things that you'd have to be aware of is just pinning. In your own code, if you have synchronized blocks, then you can use reentrant blocks or locks as an alternative. Another alternative is thread locals, but again, that's really expensive because it's got to go out to the OS and get a thread. Another option, you could just leave the code as is, but be careful, you could get millions of virtual threads, and that can bring your server down if you've got a lot of synchronized blocks. Kind of my opinion in the short term, virtual threads, they're not going to be like a widely deployed performance optimization technique. But in the future, as things are rewritten, I can definitely see a benefit. And again, they do perform better than platform threads, especially in cases where you have low concurrency or when your concurrency exceeds processor cores. That's when performance was best. So performance of blocking code with virtual threads is comparable to refactoring to use non-blocking APIs. So what this really means is applications currently using non-blocking APIs, they'll see minimal differences with virtual threads. Throughput differences will be minimal with virtual threads. Scalability should improve. Another thing, just switching gears here, that I'd like to talk about that's been in preview since Java 14 is Project Panama. This was a project that was developed by Oracle. It was named because it was trying to bridge Java code with the C world. And the way that you used to do that is through JNI. And I'm not sure how many of you have done JNI programming before. I'm very sorry. I've done that a few times. It was not fun. It causes a lot of JDK instability. You know, I guess JNI would be comparable from taking the ship around the Panama Canal, around the south tip of South America, instead of going through the Panama Canal. So it's definitely tough to develop JNI code. It is based on JEP 442, which is the Foreign Functional and Memory API. It is simpler and safer to use. They say it can have better performance, but as of Java 17 and 18, it was 10% slower. The 19 builds were 5% slower. So it is getting better. So the most amount of effort for this is to allow Java access into OpenSSL. And that is going to simplify OpenSSL 1.1 and 3 integration, which is written in C. No need to rewrite OpenSSL in Java. Leave it C. Again, this is very experimental. You have to use the enable preview JVM argument. Project has lots of potential, lots of challenges. Implementation is not near finished. The adoption will probably happen in the next JDK LTS release, which is JDK 25, which will be September 25. So why this has anything to do with Tomcat, it will be integrated into Tomcat at some point. So currently this feature is in its third preview, and it's not likely to get out of preview, even for JDK 22. And there is an example link down here of a developer that's currently, that's with the Eclipse Foundation that's doing development with this. But it is experimental. So there's kind of a cascading effect. So with Panama being delayed, what they would like to do is add HTTP3 or H3 into Apache Tomcat 11. So H3, for people that don't know, that improves user experience and performance. It handles packet loss a lot better than HTTP2. You get a single round trip handshake, reduces a lot of transmissions and delays. It's based on UDP, believe it or not, on RFC 9000. The issue is with Apache Tomcat is the UDP socket API is incomplete. But that is the OpenJIRA issue, to add that in at some point. There are other options in this link that are listed, such as reverse proxies. I think Lightspeed was maybe one of them, and I think there's a few others as well. So migrating, let's just say you're migrating from Tomcat 10 to Tomcat 10.1, or I'm sorry, if you're migrating from 10.0 or 10.1, you don't have to make any changes. It's really the imports that, like if you're doing import javax.star, that's going to become jakarta.star. So Apache Tomcat provides a migration tool. I'm going to demo that. If it can also be used as an ant task. Let's just say you have a very large code base. There's other options as well. I'll show those in a minute, but let me go ahead and go back to the shell here. And I have an examples.jakarta. Let me get rid of that. So what I have here is Apache Tomcat 9. And it's in its examples folder. It's got an example war that's got Java EE code. So if I go in there real quick, if you take a look in here, I believe it is. I'll tell you what, since we've only got a few minutes, I'll just go ahead and run it. So what this is going to do, it's just a Java application that's going to take the examples folder, and then this is my output folder. So I'll go ahead and run that. And so then if I go to this folder, I think it's examples Jakarta. Yeah, all this stuff, it basically migrated for me with that command. That used to be JavaX. So that's what that tool does. There's other options as well. There's Eclipse Transformer. IDEs also have this capability as well, such as IntelliJ. We do get a customer too that is running Spring Boot 3 on Tomcat 9. That's not going to work. Spring Boot 3 is based on Jakarta EE10. Tomcat 10 is required. There's all sorts of recipes. If you want to take a look at those, how you would migrate over, like if you were using EHCache or Jackson or any of these other packages, you can click on these links and it will tell you exactly what you need to do to migrate over. And there's also an archetype generator that's similar to the Spring Initializer, and you can choose your Jakarta EE10 or version and your platform, and then you can actually generate a POM file, or a project as well, but that's very similar to like the Spring Initializer. Also, future releases, Tomcat 12, it'll implement EE12. It will require JDK 25 LTS. Jakarta EE12 release, and this is kind of my opinion here, the releases for EE is basically 6 to 9 months after a JDK LTS release. So this would mean sometime second quarter of 26. Apache Tomcat 13 will coincide with Jakarta EE13 and so on. And then also there's been a significant amount of effort to make sure that the code bases are in line. So it used to be old versions of Tomcat had significantly different code bases. So that's something that they're taking care of. And this will give people a greater degree of confidence in code and stability of future releases. Here's some links that you can take a look at. The one at the bottom is very important. That is an active change log. Milestone 13 just came out. So if there's things that you want to see in this particular release, reach out to the community. There's also a mailing list. They communicate primarily by mailing list, so I highly encourage you to do that. So we've only got like a minute or two. I mean, I can take a question, but if you would like, you're more than welcome. I'm accessible after this session. You're more than welcome to ask me any question you'd like. But I think we'll go ahead and conclude with that. Thank you guys so much for your time. I appreciate you coming out to here.